All right. Hey, guys, we're live. As you can see, Martin is in someplace nice. I was gonna do some introduction about ourselves because you guys probably don't really know who we are, who I am, who Martin is, and I wanted to give you a little bit more of a detail on that, but we're gonna move that to the end of the lesson because I don't know, we're not sure what's gonna happen with Martin's internet connection. We hope it's gonna be great all the way through, but you know, we're just not sure. So welcome to our 8th live coding lesson. Okay, I'm just gonna imagine just froze, so we're gonna switch. Welcome to the 8th live coding lesson again. Today we're gonna talk about loops. Already scared. I don't know if you guys know anything about the loops. I don't, so yeah, that's gonna be fun. And yeah, so I'll try to add Martin again. If you didn't know, Martin is an ex-Facebook developer, so you can't really get any better than this in terms of learning to code and learning to program and learning the new programming language, right? So give it up for Martin Hagmeyer, ladies and gentlemen. Okay.
Hello, Marta. Hi. Hi everyone.
Hello, everyone. So I already said that we would be learning about the loops today. And the mic is yours.
Right. Okay. So, Marta, as you remember, we did a lot of function calls, sometimes to repeat a very similar process, but with something different. And this is exactly what the loops are for. So you can think of loops as a way of telling your program to repeat a very similar operation that needs to be repeated a number of times to get you to an answer. So I mean, we kind of like did a similar thing already with the like recursive function calls. You remember, like we had the factorial, so we needed something to happen for like a number of a number of items. The same can be done with loops, perhaps a little bit easier to understand. But it's really like under the hood, it's really like the same mechanic of coming back to the same operation with a little bit different environment, a little bit different argument. So let's imagine like you have like a list of numbers, and you need to come up like with the sum of those numbers. So you can think like you're running a business and you have like those sales figures across different products, and you want to come up with like what are the total sales, you know? So it's kind of like the Excel kind of thing to go through all the things and come up with some. So this is sort of what we're gonna do today. There are different kind of loops. So we're gonna start with the simplest ones, and we're gonna do some exercises with those, so you can see.
Okay. Okay. Should I share my screen then and go to the slide?
Let me share my screen here a little bit first.
Okay.
All right.
Okay.
Okay. Right. So as I said, so let's imagine that we start with a list of numbers that are product sales, let's say, and this is gonna be a few kind of like random numbers. So right now, like this program obviously is only gonna like return the value that I inputted, and the task is what is the sum of product sales.
Right.
And there is a couple of ways to approach that. So the first way, you could have a recursive function do that. So that would go like const recursive sum. And this recursive sum is going to require an index where it needs to start. So that would be index. And it goes like, oh, okay. Made a mistake there. It actually goes like this. So you have the fun keyword and the index. So we go like if index is more or equal the product sales. I think it's size or length, perhaps, or maybe size. Yeah. So then you return 0. So it's like saying, okay, the recursive sum, if someone calls it with the index that is larger than or equal the number of items in the product sales, then the sum is 0 because there is no items with this index. Otherwise, we're gonna do return. Otherwise, we're gonna do product sales from that index plus recursive sum of index plus 1. So it's like saying, okay, so if someone wants the recursive sum of index 1, then this is gonna be the product sales at that index, and also the recursive sum of everything that comes afterwards, if that makes sense. So if I go recursive sum of 0, that should give me the answer here, 128. Kind of like a fun round number we got here. It's yeah, I think it's all right. So does that make sense, Marta? Let's see how. I just want to like start by repeating a little bit about those recursive functions first.
Hold on. Like, what is the index? Why are we using an index?
Oh, okay. Because like if you do a recursion, you sort of like need to divide your operation into certain steps. So you can go like one step at a time, and then you do this one step, and whatever comes afterwards is gonna be another function call that we see here. So recursive sum is a sum of those numbers starting from that index, right? So this is what is the sum of product sales starting from index. So this is sort of like the question that we are answering with this. So recursive sum starting from index 0 is going to be the entire sum, correct? Because the index, because 0 is the first index. Does that make sense?
Does it mean it's supposed to start at 12 within that list?
Come again?
Does it mean it's supposed to start with the first item, which happens to be 12 here? Is that what it means? And then it's supposed to add other numbers? Can you hear me?
Yeah, I didn't wasn't getting that for a second.
Okay,
Come
so
again?
we have the text. Does that mean when you're like calling for recursive sum and you have a 0 as an index, does it mean that it's supposed to like do what? Start with the 12 with the item number 0, which happens to be 12 here, or like what? I don't think we had index before, or like, is it something that's already here, or are we just calling an argument an index?
You are breaking up a little bit from.
Oh,
Maybe you
okay.
can. Maybe you can write. Maybe you can write the question in the chat, perhaps.
Okay, can you hear me now? Maybe I don't know what happened. Why am I breaking?
Yeah, not so well.
Is this better or not?
Yeah, this is better. What did you do?
I just got closer to the mic.
Okay. Yeah. All right.
Sorry,
Thanks.
maybe it's not connected or something. Okay, so I don't know what's happening here because I don't know what that index is.
All right. So index is the starting point. Index is the starting point.
It's 12, right?
Yeah. Index is the starting point. So this is this, and recursive sum of like 2 is gonna be the just this, because like the indexes you see.
Okay, yeah. So it's the point. It's the exact point where it's supposed to start.
Yes,
Adding.
this is exactly what we call by index. Yeah.
Yeah.
So
Okay.
it's like saying the recursive sum. So what is the recursive sum? The recursive sum is the item at that index, and also like the recursive sum of the rest. So that's how it's. So that's how it goes. So you get the recursive sum of 3 is gonna equal like product space of 2 plus of 3. You see, Marta?
Yep.
This is like a simple formula that we kept using before. It's like you divide this operation into smaller steps. You do one step, and then you do everything that comes afterwards.
All right.
Okay.
Is this a loop or not really? It's a recursive.
This is not this is a recursive. This is a function. So we call it a function. So what this function does is kind of like the loop behavior actually. But just for like the matter of like dividing programming constructions into different things, this is a function, and it does the looping behavior for two reasons. The first is it calls itself again with a different index, so it like enters the same operation but like one index later, one index forward again, right?
Yeah.
And the second reason why this is actually a loop kind of behavior is that it has a stop condition. It's very important, the stop condition. If you don't have the stop condition, then your program is gonna run forever. And like in our environment, this is gonna result in the oversteps limit, to let you know that you perhaps are doing more steps than is necessary to make the computation. So this is why we have this condition. This is a stop condition.
Right. I got it.
Okay. So does that make sense?
Yeah.
Okay. Awesome. So this let's call this the recursive solution, and I'm gonna keep this at the end, right? So here is like the task. And here is one solution. Okay, so the second solution is actually gonna involve loops. So it's going to be a for of loop.
Ooh.
So that thing is a little bit different because first of all we need a counter. We need something that's gonna aggregate the result here. So let's create that. It's going to be the for sum. I'm gonna call it sum A because it's a sum solution A. Okay, sum for solution A or sum for A. Okay. So we start with 0. That's the initial value of the sum. Okay.
Mm-hmm.
And the for of loop is pretty straightforward. It says for. The for is you're gonna see that often every with loops. It's saying like for every element I want to do something. So for instance, you say for const lm for element of this product sales. So this is like saying, hey, inside those curly braces, I want something to happen for every element of the product sales, and this lm is how I'm going to reference this element, right? So this is going to be executed 5 times with lm being each element 1 time. So it sort of like goes step by step. Does that if that makes sense?
Yeah.
So here, what you need to do is just say sum for A equals sum for A plus this element. It's really that's it, you know. So you need at the end you need to return the sum for A to get the result. You see what happened? Like so this gets executed for every element of the product sales. So if I was to change the formula a little bit, or maybe like keep it like this, but just add a different thing just for you to see. Let's say count 0. So if I was also increasing the count, then sure enough, I would see count A. Okay, yeah. Pewnie kartą.
Oh no! Did we lose? Did we lose Martin, guys?
Can you hear me?
Yeah.
Okay. Okay. So, do you know why we got 5 here?
Where is the 5? Because we have 5 elements basically.
Yes, exactly. So if I added like 64 here, that would extend the array by 1 element, and it would cause the for of loop to be executed 1 more time, and that would mean that the count is increased 6 times, and that's why it's 6. It's really, you know, as you can see, a pretty straightforward a loop here.
Mm-hmm. But it's like way different way of writing that function. And is LM is it something that you created, or is it?
Yeah, it's completely something that that I created. So you can You can call it differently, like a product sale or like one product sale. And you do like here, you end up with the exactly same thing. What you see here are the sort of like the arguments for the for off loop, making it easier. So I mean, as you can see, if you only want things to happen for each element of the array here of the list, then you can go with the second solution, which is just easier, maybe shorter than the recursive sum, but it's really does the same thing.
Yeah. Okay, so you don't have to write, you don't have to let it know when to stop because it's just gonna execute on each element.
Yeah.
Yeah.
Okay. Yeah. Okay. So are you ready for some? There are more kind of loops, but I think it's more important to like focus and exercise on this one. So and this is I think this is the simplest loop. Once we get a hang of this thing, then we can do more stuff.
Okay, we can try.
Okay. Okay, I'm gonna stop sharing now.
Okay, and I'll start to share my screen. Right. Okay. What's my mission?
Okay, so for this exercise, let's first start with having an array. Can you just create an array of some eight random numbers that you just type in?
Okay, so let A be our array with numbers with 8 digits, right? 8 numbers. This is it.
Okay, yeah. All right. Okay. I didn't mean for those to be consecutive or anything, but we got what we got. Okay. So okay, could you so let's start with like sort of just the repeat. Maybe how about like can you find out the product of those? So what is the value of all those numbers multiplied together?
Not added, but multiplied.
Yes, not added, but multiplied. Exactly.
All right. So, okay. With a loop, I'm going to try to make it with a loop.
Okay.
So let M is going to stand for multiply. And we start at 0, which, if I understand it correctly, it says that it has to start executing the function in the first place, which is place number 0, which is here. Okay. I hope it makes sense. Anyway, then we're gonna go for, and we create. You used const here, so I'm just gonna use const as well, and I'm gonna go with x. Yeah. So for each element of that list, that array.
Remember you say const x of and then you provide the array.
True,
Yeah.
of a.
Yeah.
All right. Sorry. Then we have to tell it what it's supposed to be doing. So it's supposed to take M and I hope that's the right symbol here.
This yes, this is the right symbol. Maybe it would be easier to write this program if you used a longer variable names, because that's what happens here. Like A stands for the array, and X stands for one element. So what you really want to do, yeah, okay.
I'm just gonna go array here. Array. Yeah. Okay. And now we're gonna call for return M. Why? Why is it 0? It's not 0. I don't have zeros here. Why does it return 0?
I'm not gonna say anything. I'm just gonna smile.
This I'm just saying to start here, right? So it doesn't tells it to take 0 and multiply it or anything like that. But
so
also it says that this is 0.
Right. It says M is going to be something else, and the something else is M multiplied by X. So when this for loop enters its first operation, then X is the first element, being 1, right? So what happens then? We call it the rubber duck debugging, when you explain what the program does step by step.
Crap, it takes 0 and puts it right here. So everything multiplied by it will be 0. But like, how did you write it? Like, how did you?
So for addition, 0 doesn't matter, because anything when you add 0 to it, it's the same thing. But with multiplication, it's different. Like whatever you take, you multiply by 0, it's 0, right? So it's different. Yeah.
But I thought it was just no. It's okay. I thought it was meant to do something else. But so like
It serves the same purpose, but it works a little bit different for addition and for multiplication, because 0 is neutral for addition, but 1 is neutral for multiplication. It's different in that regard.
So that should work now. And I don't have a calculator right here, so I'm not gonna check it if it's true.
I mean, well, the way you wrote those numbers, it's I mean, it's you should already know what it is. I mean, right? How do we call the product of consecutive numbers? Like,
I don't know. Factorial probably.
yeah, there you go. That's the word.
Oh, it works. Still works. Okay, it works.
Awesome, very nice. Okay, let's do something else now, because that I feel like that went pretty smoothly. So another interesting thing that you could do with the for of loop, you could be counting specific elements. We call it like sort of like a filtering a little bit. So we can start with the same array. Yeah. So the question now is like how many elements in this array are less than 10? If you had to count it, like how many of those are below 10? How would you approach that?
Well, it would have to take every single item and check if it's less than 10 or not. So
yeah.
So let me start from here for const x of array, and just take it. But how do I tell it to check, actually? I don't want to tell it to add or multiply, I just want to tell it to check.
So it seems like you need something to happen only if certain conditions are met. So this is we call it a conditional code. And whenever you have a conditional code, then you should be thinking if.
If statement, okay. Should I put it right here, if, and then condition, or should I put it right here below? Maybe below.
Do you need it to happen for each element, or do you only need to happen once?
I need it here probably, because I need to check every single item of that array. So if x is less than 10, then you need to take the x and
well, you need seems like we need to have like a variable that's going to accumulate this result. So like we need a place where we're gonna keep writing down the result of the operation. So we need like a counter or
I can do it.
Sort of like M you had, yeah.
I can do it other way. If x is bigger or equal than 10, it just will be excluded. So can I return 0 then?
Well, if you can do this, but remember, return is going to end your program. So
oh crap.
Yeah, perhaps not what you need. Something you might use, like remember, like on line 3, you had this M variable, and you use that repeatedly to aggregate the results. So you could use a similar approach, but maybe call it counter, and this counter should change somehow inside that loop.
Oh man.
Well, I mean, that's simple. This is what you say here is the beginning, the initial value of the counter. So before we start counting, what's the value of the counter?
0.
Yeah.
So then, but I'm stuck here. Like I don't want. What do I say? If it's Okay, let's go back to this then. If that happens, just count the numbers. So take counter and counter plus, hold on, plus x. Right? Because these are x's. Every single one is an x. Martin, are you there?
I am there. Yeah, I'm there. Let's maybe when we do testing, we can see if this is what we want.
But I also I have to tell it to, else maybe or not.
I mean, not really, because we only care about the numbers that are below 10. The other numbers we don't care about those.
So this is not what I wanted.
Right. I mean, you need to return the counter at the end. Remember, because like otherwise your program is not gonna know that what is it counting really.
Jesus, true. Where am I? Here?
Here you are still inside the for. Remember, right? So,
Nice.
yeah.
Here. Thinking. Okay. What if I want just the less than 10? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Looks good.
This looks more like a sum, though. I thought we were just counting those numbers. So should that not be 7?
Oh, yeah. Okay, so I did, because I did the sum right here.
So every time we see a number that's below 10, what is it that we want to do?
Count as 1.
Yeah.
Whatever the value of the number, it has to count it as 1. So
Yeah.
So where do I write it? Like counter plus 1, right?
Yeah.
Okay. Oh man, that's tense.
Awesome. Can you change the array a little bit to see if your program is still gonna work?
It works. Yeah. It works.
Oh, and it started raining.
Oh.
That's awesome. Man. Okay.
Oh no.
Hold on. I need to move.
Okay. You guys, this is not easy, but yeah, it makes sense.
Okay. Here I'm safe, I think, unless it's a thunderstorm, which I don't know.
I mean, like, did you expect anything else than the storm?
No,
Really?
not in Poland. I didn't. Yeah.
Yeah.
All right. Cool. Yeah.
During this lesson, it's just a common thing that there is a storm outside. So, Okay. What's next? Do we want to do one more example? I feel on fire. We can do it. I can do it, I think.
Yeah. Okay. So can you do sum of squares of this array? So
What? Ah, okay. So sum of squares. So we have to start with 0 because it's a sum.
okay, very nice, very well.
Yeah. So we take 0 and then we go. We actually. Stop. I don't know how we did it. Do we create another function like no, it's not sum of squares.
Yeah, that would be like another counter for like the sum of squares, maybe, or you can keep call you can use repurpose the counter. That's also fine if you want.
So I don't want to do +1 because I'm not counting numbers.
So for every element, you need to take the square of it and add it back to the accumulator thing. Yeah.
Like, do I need another? Okay.
unless this is some kind of like ASCII art that you're doing here, that
I don't know. Like, is it gonna understand what I'm trying to say? Like, I probably need another.
yeah, that should work. Yeah, that should work. Also looks pretty cool too.
But you told me that it doesn't know that it has to multiply first and add later, and we have a plus here and multiplication here. So I think it's gonna add these two first and then multiply it, but that's not what we want.
Yeah, you need parentheses, sure. So you need to wrap in parentheses, but just the round ones, the round ones. The square ones we use for something else. Yeah.
All right, I'm trying to do some old school math here, but it won't work. So okay. Let's see. 89. Well, that doesn't really look. Oh, but for the digits below 10. So yeah, it might be true. Let's see for ones. Okay. 1, 2, 3, 4, 5, 6. It's 6. It's 6. Okay. What if we have 5 and then 4? Okay, fine. Looks good.
Marta, about the line 14, you don't need as many parentheses. Like around x, you don't need those.
Oh, true.
Yeah, it makes it a little bit easier to read. Yeah, good job.
Okay.
Right. Yeah, I think I think for just for the simplest loops, this is it. Really, something to remember. Like this kind of loop allows you to do stuff for every element of an array of or some other like collection. So if you have like a bag of things or like a set of things, and you need stuff to happen for every one of those, then for off loop comes in handy. However, like it usually needs some additional like counter that you need to have in order like to keep adding
Right.
values. That's something that the recursive function does not need externally, because it can have like an argument, right? So when you had the recursive function, you can provide its argument, and it's like there, it has everything it needs. But with the for off loop, it requires usually this additional counter. So, I mean, it's a matter of taste. Like the for off, it's more like a imperative style programming, and the function is more functional style programming. So it's really like you can decide which one of those fits better your use case.
I like this for off actually. It just makes sense, and I screwed it up a little bit because for some reason I thought like this would tell it to where to start in terms of physical place within the array. So if I had like 3 here, then I thought it would say start at number 3, which is here, and then keep adding these things, but that's not what it is. So now I get it.
Okay.
Yeah. Let me just stop sharing my screen for now. All right. Okay. So yeah, I wanted to make a short introduction of who we are, because we never really said who we were, except for the fact that I don't really have any experience in programming. And so we work in the company called Xfiles, and Xfiles is a company that hires people or developers from FANG companies. And FANG means Facebook, Apple, Amazon, Netflix, and Google, right? So Martin, for example, is a developer with previous experience in Facebook. And we have other developers with experience in Google or Amazon. So the FANG companies, right? That's why Xfang. And Xfang, in Xfang, what do? We do software development, we do security and compliance, we do some tech roadmaps and stress testing and scalability. So we kind of solve all the software development / IT related issues brands or companies might have. And yeah, so it's a really cool opportunity to actually learn from ex-Facebook or ex-Google developers. And in these lessons, you will actually learn from Martin, and I'll be learning as well, who is an ex-Facebook developer, right? So this is big. This is big. You can't really do any better than this. You know, you can you won't be learning from a better person than an expert developer, to be honest, right? Just confirm.
Okay.
And yeah, so that's. I also wanted to maybe sum up my previous experience and that's what I wanted to show you guys, because I did some old school coding with pen and paper, and I had to break this code down into actual steps to actually understand it, because I couldn't understand where's the counting coming from, and that helped me. Also, be aware that learning to code, learning the new programming language, especially from people who are fresh to all this jazz, is it's tough, and it's highly high cognitive. Did you say something, Martin? Did you say something?
Oh no, this is just noise. Sorry.
Oh. Okay, so it's a high cognitive load task, which means you can get cognitive overload pretty easy, which, you know, there's a lot of things you will learn. So you learn the new syntax, you learn new words, you have to remember to name arguments, to name function and how, right? So just try to keep it simple. And that's what Martin always says, to keep it simple and to break the bigger task into the smaller ones. That's what helps me. And like, if you are stuck, you might actually try to break down the function into like the easiest steps and take just 2 steps instead of 8 or 10, and just to kind of understand how it actually works. And one thing which helps me, not always though, as you had a chance to see, because I kind of want to name functions and arguments the shortest name possible. So I would name everything X, Y, and Z, or ABC, instead of sum of products or whatever, because like for some reason my mind won't operate on like long names of functions and arguments. I don't know why, but keeping it down to like very short names helps me. So maybe that will also help you. So yeah, that's what I wanted to say. Just try to, like, if you have problems understanding, just like me and probably like many more of us, try to break the problem down into the steps, into the easy steps, and instead of running the program for 8 times or 10 times, just try to run it for 2 times and break it down into those 2 times to see how it works in those steps, and then it would make sense. At least that's how it works for me. And maybe, yeah, it's with the naming, it works for me to name it in the shortest way possible, but it also should make sense, because when you have like function A and argument A and then function Y, then you actually don't remember what it was all about, right? So
Marta, unfortunately, I will. What you say here makes me very happy, because it makes a lot of sense, and these are good tips. Unfortunately, I will have to run because of my battery. And please remember to check out the comment section before you wrap up.
okay. So
Bye.
thank you, Martin. Bye bye. Okay, we're gonna just cut him off. And comments. What do we have here, you guys? I change second variable m. That's what I did. Yeah, thanks. I was just I thought it would do something else, but after a while it totally made sense. So thank you. And then Carolina, I like this an idea about free lesson. Thanks, Carolina. Like, yeah, you guys are welcome. And yeah, we're going to do some cool stuff. And you know what? I'm always available here on Facebook, or maybe not on Facebook, but just you can find me on Twitter. And I think I'm open to respond to any of your questions. If you have any, just let me know, and I'll try to help you out with that. And yeah, I'm really happy you like this idea, and we like this idea as well. And you guys are all welcome. So join us every Monday at 7 p.m. and we're gonna do some more coding then. We're gonna have another lesson next Monday at 7 p.m. GMT +2, which is Warsaw time zone. And we're gonna do some more coding. At some point, we will start the project. So you're gonna see how it is to use AskQL in more practical way. And you guys are really all invited. And I'm happy we're getting some comments. Thank you, guys. What else? I think that's it for today. We did some loops, right? And I'm just checking if there are any fresh comments, but that's it for now. So yeah, you guys, I got some questions about making little bit of an introduction. So my name is Marta and I work with Xfunk. I help the company with some day-to-day operations, day-to-day tasks, some administrative tasks as well, and some communication. But I don't really have any previous experience in coding, in programming. I know HTML, CSS. I'm getting better, but I'm not like a super pro yet. And now I'm learning AskQL. So, so yeah. I got the comment that there are lots of fans on Node.js group. You guys, thanks. And just let me say that I've installed Node just like a few weeks ago. So I'm getting to know that too. All right. So if you're fresh to this coding thing, to this programming, just like me, you guys, like two things. One thing is it's important to find a mentor, like a person who's actually going to help you with your issues, because sometimes you just get stuck and you don't know how to proceed and you don't know what the next move is or what you should do in the next step. So a person who's more experienced than you, who can help you with this programming thing, and who can actually tell you what to do if you're like completely stuck, is a great way. And yeah, you have these programming lessons which are free, and we are always ready to answer any of your questions. If you get stuck or whatever, just hit us and we are trying to help you. And the second thing is just, it's a hard thing to learn. You know, everything is new. The way to process things is new. Syntax is new. Things, let's call it things within that syntax, are also very new. So if you get this feeling that you're not really getting better as a developing, so you can just stop, because you might be not knowing this, but you are. So just remember, it's a long run, and you're gonna get better eventually, and you're gonna be conscious about this progress. Just don't freak out, okay? So yeah, mentor, which could be us here, and just don't freak out. Let yourself learn in your own pace, and you're gonna be just fine. Okay. That's it. That's all I wanted to say for today. And thank you very much. I'll see you next week on Monday at 7. And you guys have a great evening, and see you next week. Bye-bye.